Oh, hi, welcome to Science in 5. If this is your first time here, you probably want to subscribe and hit the notification bell icon. In that way, you'll be kept up to date with all our news and information. And if we upload a video, hey, you'll probably hear about it, okay? In this video, we're going to discuss Coulomb's law, type 3 calculations. Make sure you've watched type 1 and type 2. Okay, we're back again. Electrostatics, 3 types of calculations that you need to focus on involving Coulomb's law. These are not the only calculations, but they're like the most basic calculations, which means you gotta know these. You've got to know these. Come on, gotta know them. Okay, so in the last question we said when you've got more than 2 charges, free body diagram, figure out the direction of the forces, then calculate the forces. In question 3, that's exactly what we're going to do. Let's first, we want the net force on Q3. Okay, so calculate net force on Q3. They're going to be vectors in 2D here. Because they're going to be vectors in 2D, we'll need to use a top and trig method. In other words, we're going to use the Theorem of Pythagoras to get the resultant, and then we're going to use a trig ratio to get the direction. So I call it the top and trig technique. Top and trig. Sounds like a duet, you know, like two rappers, you know, like, yo, it's top and trig. Okay, don't get carried away. Let's not get ahead of ourselves. Stick to the question. The net force. Free body diagram on Q3. Let's start. There we go. If I was Q3, now I can see that all these are positive charges. I suspect I'm going to need more space. So they are all positive charges, right? So let's place Q3 there. What does Q1 do to Q3? It's a repulsion. So Q1 is going to push Q3 out. So there's the force from Q1. Go away, repulsion, don't want you here. Q3 versus Q2. Q2 is going to push Q3. Remember, we are focusing on Q3. So Q3 is going to be pushed by Q2. Does that look perpendicular? Nah. That is not. There is not perpendicular. That it was perpendicularish. Much better. Much better. Now, there are the 2 forces. They're perpendicular. Where is the resultant force going to be? I could employ the parallelogram method. The parallelogram method say, with these 2 sides, I can make a parallelogram. Draw one side parallel to FQ2. Draw one other side parallel to FQ1. Why is the FQ1... What's wrong? This diagram, what's up? I'm rubbing and what's happening here? Because now it looks like... Okay, FQ1 is this one here. Come on. Okay. Once you draw the parallelogram, the resultant is from where you started to where you ended, where the 2 heads meet. So my resultant force should be this one there. That's F net. And I always like to calculate the angle theta from the horizontal. So if I can determine F net, I might as well calculate the angle as well. So this is the right angle triangle. This side is also FQ2. Oh, there got 2 perpendicular forces. That's why I can use the Theorem of Pythagoras, the top and trig technique. But before we get to the top on trig, we need force Q1, we need force Q2. So force Q1 is going to be K, Q1, no, force Q, let's start with force Q1. Okay, we're starting with force Q1, the one going that way. K Q1 times Q3 all over R squared. The K is 9 times 10 to the power 9. Q1 is 2 times 10 to the minus 5. Q3 is 1 times 10 to the minus 5. Distance is 1 meter and it's 1 squared. We already got the distance in meters. No need to convert anything there. 9 exponent 9 times 2 exponent negative 5 times 1 times 10 to the exponent, again, negative 5 over 1 squared, 1.8 newtons. That's what FQ1 is. What of FQ2? The force from Q2 is K times Q2 times Q3 over R squared. 9, 10 to the power 9. Q2 is the 1, 2, 10 to the negative 5. Q3 is the same as 1 times, or the same as 10 to the negative 5, because 1 times that doesn't change anything. All over distance 1,25 squared. Calculator, hello. Now, 9 exponent 9 times 1.2 exponent negative 5 times 1 exponent negative 5 all over 1.25 squared. 0.6912. 6912 newtons. This time I'm not going to add, but I have to use the Theorem of Pythagoras. So the net force, F net, is the square root of 1.8 squared plus 0.6912 squared. So this square root sign must include everybody like that. Okay. So from then on, square root 1.8 squared plus 0.6912 squared, 1.928 newtons. 1.928 newtons. I can round off to 1.93. Fine, it's fine. I can leave it as 1.928. Fine. Okay. Now I've got the net force. Now I need the direction, the angle theta. What am I going to do? Oh yeah, use the tan. We know from our maths that if we've got an angle measured from the horizontal to a line, we can use the tan to get this angle. The tan is going to be the y over the x. So I'm going to say the tan of theta is the y vector over the x vector. So if you do this approach where you deliberately mark this angle from the horizontal to a vector, that angle there, theta, always from the horizontal to the vector. If you mark that angle, you can easily calculate this angle by using this relationship. The tan of theta is the y vector over the x vector. Only if you are measuring the angle from the horizontal to the vector. If the angle goes there, then you can't use this relationship. Okay. Right. Now, What is the y vector? The y vector is fq2. And we know that fq2 is the 0,6912 over the x vector is fq1, 1.8. So which means now theta is the arctan of that ratio. Okay. So shift tan. The ratio is 0,6912 over 1.8. 21,006. or 7 degrees. Okay. Now I've got the angle. I now need a direction. Okay, I now need a direction. So the north is going upwards. So FQ2 is acting along the north, FQ1 along the east. So my resultant is between the east and the north. So I could give the direction as direction (21.01 degrees). From this is the east. I'm going towards the north. So I'm coming from. So I'm going to say north of east. Or, now that I know this angle, I can work out this other angle. We call that beta. So beta plus theta should be 90 degrees, complementary angles. I can now say, oh, all right, 2101, 90 minus 2101, 90 minus 21.01, 68.99. Or I can say this is 68.99 degrees. This time I'm going from this direction, east of north. Or last I can say, well, the north can be taken as 0 degrees. So bearings are measured clockwise. Or I can say at a bearing of 68.99 degrees. Okay. This time around, the charge has formed a right angle, the assemblage of charge. Again, we started with the free body diagram. But this time around, we used a top and trig technique. First, we found the force, the two perpendicular forces. Then we used the theorem of Pythagoras. That's the top. Top means theorem of Pythagoras. Then trig, we used the tan. Remember what I said? The tan theta is y vector over x vector, provided the angle of interest theta is here between the horizontal and the vector. Always you can use that. Once you get the angle, convert it into a direction. Now you can do these 3 calculations. You sorted. All the other calculations are variations of this. Okay, I hope you've learned some skills, and now you know how to do a top and trig, how to find the net force, how to use Newton's third law as well. The force that the two charges exert on each other is the same. Sharp, sharp. I will be catching you guys later, okay, when we start making things even more exciting. Give the force. Can we work out an angle? Given the force, what's the distance? Given the force, what is one of the charges? Now we can be able to do those calculations. But first, this is our basis, our starting point. So make sure you familiarize yourself with these guys. Okay, my time is up. My time is up. I will be seeing you guys on next time. Same channel, same face. And hopefully let's make physics exciting. And yeah, this is awesome, man. This is great stuff.